All right, today we are in Unit 5, Lesson 5, again out of Chapter 11 from the textbook. Today we're going to be looking at the normal distribution. The content center we're going to be focusing on is use the mean and standard deviation of a data set to fit it to a normal distribution and to estimate population percentages. Recognize that there are data sets for which such procedure is not appropriate as well, and use calculators, spreadsheets, and tables to estimate areas under the normal curve. There's two mathematical practices we'll be looking at. Number 6, attend to precision, and number 8, look for and express regularity in repeated reasoning. We're going to start off with the definition of what a normal distribution is. There's 4 points for this again, just like there were 4 points for the binomial distribution in the previous lesson. The first point for the normal distribution is that the graph of the curve is continuous, bell-shaped, and symmetric with respect to the mean. So that means it's centered at the mean and it's symmetric. Like we've looked at in the previous lessons, symmetric versus skewed. This normal distribution is always symmetric. Another unique feature is that the mean, the median, and the mode are all equal and they're all located at the center. The curve approaches but never touches the x-axis, so that means essentially that there is a horizontal asymptote along the x-axis, and the total area under the curve is equal to 1 or 100%. So when we looked at probabilities in binomial distribution, the same way all the probabilities had to add up to 1 or 100%, all the area under the curve for a normal distribution also adds up to 100%. Here's a visual picture of what a normal curve looks like. And this, on the slide, we're going to be looking at the empirical rule, which is one of the most basic rules for explaining how much data is within a certain amount, certain portion of the normal curve. So if your mean is mu, and that's right at the center, the empirical rule says that 68% of your data is within one standard deviation above or below the mean. So if we go 1 up, we have 34% from here to here. If we go 1 down, we have 34% from the mean to -1 standard deviations. Together that makes 68. If you go 2 standard deviations away on either side, together that makes 95% of your data. And if you go 3 standard deviations away on either side, you get 99.7% of the data. So essentially, and we focus on this a whole lot more in AP statistics, essentially all of the data is within 3 standard deviations of the mean. Obviously there's a little piece that isn't, but for practical purposes, pretty much all of the data is within 3 standard deviations of the mean. So using the empirical rule, we're going to look at example 1. It says a normal distribution has a mean of 45.1 and a standard deviation of 9.6. Find the values that represent the middle 99.7% of the distribution. So the first thing that we should think about immediately is that if they say 99.7%, that means 3 standard deviations around the mean. So if we know the standard deviation, we're going to need to multiply that by 3 and then add and subtract that value from the mean, 45.1. So that means that the values that represent the middle 99.7% would be any value that's between 16.3 and 73.9. For part B, it says a normal distribution has a mean. Okay, same scenario. What percent of the data would be greater than 54.7? So when you think about this, what you should do is recognize what's the significance to the number 54.7. And again, because this is the very basics of statistics, they're making the math a lot easier for you. So essentially, if you take 45.1 and you add 1 standard deviation, 9.6, you get the number 54.7. So that means it's 1 standard deviation away from the mean, and 1 standard deviation, according to the empirical rule, it shows that 68% of the data is going to be between there. But because we're only going greater than this number, outside of 68% would be 32%. and we're only concerned with the upper end because we only care about what's greater than 54.7. So we need half of the data that's outside 68%. And I'm going to go back to the slide real quick. So if we're right here at 1 standard deviation, we only care about what's up here, what's greater than 54.7. So essentially you're just adding these two numbers together, which is 16%. Okay, we've got to check your progress problem. Go ahead and pause the video, work your answer out, and when you have your answer, go on to the next slide. Okay, our answer this time is B, 2.5%. Example 2 is a real-world problem. It's about packaging. It says the students counted the number of candies in 100 small packages. They found that the number of candies per package was normally distributed with a mean of 23 candies per package and a standard deviation of 1 piece of candy. About how many packages have between 22 and 24 candies? So again, because they're talking about 22 and 24, and we know the standard deviation is 1, that means these numbers represent 1 standard deviation away from the mean of 23. 1 standard deviation is 68% of the data, so we need to find 68% of 100 packages, which would be 68 packages. For part B, now the question is, what is the probability that a package selected at random has more than 25 candies? So 25 would be 2 standard deviations away from the mean. But we want to know what percent is greater than 2 standard deviations away. So we need to remember from the empirical rule that 2 standard deviations is 95% of your data. So there's 5% outside the distribution. But we only care about the upper side, so we take half of that number, which is 2.5%. So there's a 2.5% chance that the package will have more than 25 candies. Okay, we've got to check your progress problem. For example 2, go ahead and pause the video, read through the situation. When you have your answer, go on to the next slide. This time our answer is choice D, 81.5%. Okay, next we have the key concept for finding a z-value. It says the z-value for a data value x in a set of normally distributed data is given by the formula z equals x minus mu divided by sigma, the standard deviation. So this essentially, it means if you are given a value x in a scenario and you subtract the mean from it and then divide by the standard deviation, you get the z-score. The z-score is a huge focus of AP statistics. Again, we're just covering the basics here, so this isn't going to be super complicated, and you might not fully understand what it means, but it's a simple formula to apply. So example 3 says that we need to find the standard deviation sigma if x is 28.3, mu is 24.6, and z is 0.63. Indicate the position of x in the distribution, meaning graph a normal curve and show where x would be. So we're going to apply the z formula, plug our numbers in, solve for sigma, and we get that sigma is about 5.87. The standard deviation is about 5.87. And that's about 0.63 standard deviations greater than the mean. And we can tell this number is because of z. Z shows you how many standard deviations a value is away from the mean. So if we were to graph this on a normal curve, let me try to graph this. This is going to be not perfect. But let's say this is our normal curve, and this right here is the center. That's mu. This right here would be about 1 standard deviation away. And we know that this number right here, I believe was 23.9, and then 1 standard deviation was 5.87. We're about maybe here. So about this number. That would be about 0.63 standard deviations away. If this is 1 standard deviation right here, this would be about 0.63, just indicating where it would be along the curve. Okay, next we have a check your progress for example 3. Go ahead and pause the video and apply the Z formula. This time you're looking for the mean mu. We'll see the answer on the next slide. And our answer this time for the mean is A, 26.082. So, some characteristics of the normal curve. The total area under the curve is 1 or 100%. We've already talked about that. Pretty much all of the area. So this is a standard normal distribution. The standard one always has a mean of 0. And the 3 standard deviations are the values 1 and -1, 2 and -2, 3 and -3. So you have normal distributions that can have any mean and any standard deviation, but the standard one always has a mean of 0 and a standard deviation of 1. This is the curve that you would use based off z-scores. It's symmetric. All the other properties apply to this that also applied to the basic normal distribution that we looked at earlier. For example 4, it says the cholesterol levels for adult males of a specific racial group are normally distributed with a mean of 158.3 and a standard deviation of 6.6. Find the probability. Then use a graphing calculator to sketch the corresponding area under the curve. And we're finding the probability that x is greater than 150. So what we need to do first is find the z-score that corresponds to the value of 150. So we need to apply our z formula, which is x minus mu over sigma. We're going to plug in the values that we're given, and we end up with a z-score of negative 1.26. It says using a graphic calculator you can find the answer. Well, that's true, but how? Because they don't show you how. So we're going to go over to our graphing calculator, and I'm going to demonstrate how this is done. So once we're on the graphing calculator, what we're going to need to do is go into the y equals menu, and then we need to sketch a normal curve. So the way the normal curve is drawn is by hitting second vars. You want to pick the first option, normal PDF. You can just go down and hit paste. And, we need to type in. It doesn't really matter what number you put because we're going to delete this out later. Go back here and delete everything that's after this, and then just press X. Then go to your window. The window should be negative 4 to 4, counting by 1. Your y-min needs to be a little bit below 0. We're going to go with negative 0.1. And the y-max we're going to use 0.5. Hit graph. So this is what a normal curve looks like. And then if you want to find the area back here, that's between all the area that's greater than the z-score of negative 1.26. What we need to do is go into second trace, choose option 7. The lower limit, because we're finding what's above negative 1.26, our lower limit would be negative 1.26. The upper limit, you're going to pick the end of your graph, which would be 4. Hit enter. It's going to shade it in, and it will show you the answer down here, which is 0.896, which rounds to about 90%. So if we come back here, you can see how they got the answer of